before we get into problem 1, we have to learn how to recognize a perfect square trinomial. Now, if the first and last terms are perfect squares, then you could have a perfect square trinomial. So if you have an a squared at the beginning, the first term and the last term, and then a b squared at the end, you could have a perfect square trinomial. The second thing is that the middle term is twice the product of one factor from the first term and one from the last term. So it's twice a times b. Okay, so for example, if we're looking at actual numbers here, let's look at these first numbers. Here we have a 4n squared. So the first and last terms have to be perfect squares. So 4 is a perfect square because 2 times 2 is 4, and n squared is perfect square because n times n is n squared. So that would be 2n squared. So that's a perfect square. So 2n quantity squared, that is a perfect square. Then the last one, the last term also has to be a perfect square. So 9, of course, we all know is a perfect square because 3 times 3, or 3 squared, is equal to 9. Now let's take a look at the second requirement. The middle term is twice the product of one factor from the first term and one factor from the last term. So that just means 2ab. So here, if I take 2 times the a, which is 2n, times the b, which is 3, so then that's 2 times 2 is 4, times 3 is 12n. So there's 12n. Okay? And then, of course, you have to take into consideration if you have a plus or a minus, or a subtraction or an addition. All right, so let's take a look at problem 1.